All right, so we are going to try to finish up what we started yesterday. I kind of gave you a hint yesterday of what we're going to be talking about today, so let's get right to it. Let me turn this graphics tablet on so I can write on this thing. So we are going to talk about parallel lines. Yesterday, for the most part, we did not talk about parallel lines. At the very end, we did. At the very beginning, the very end. But in between, we just talked about any two lines cut by a transversal. And we know the names for all those. Do you remember the names for them? What was the first one that we did? You can look in your notes. Corresponding angles. Okay, I'll just shorten it up a little bit. Okay, corresponding angles. And then the second one was what? Alternate what? Interior angles, right? The third one, alternate exterior angles. And then the last one that we did, they were what? Consecutive. I gave another name for it, that a way that some books name it, same side interior, but in this book we're going to call it consecutive interior, okay? So let's use their phrase since we're using their book, okay? So consecutive interior angles. Those are the four things. You need to know those names. I'll eventually give you a quiz on this stuff, and when I give you a quiz, it's going to say, it'll give you like angle 1 and angle 5. What are they? And you have to know if they are corresponding, alternate interior, exterior, or consecutive interior. I think I even give you the list, though, okay? So you don't have to memorize all four of them. You just have to look at that list, and you got to know which ones are which, all right? That's pretty easy, isn't it? All right, then after that, on the quiz or a test, you're going to have to be able to find what angles are equal to each other, and that's what we're doing today, all right? We're finding what angles are actually equal to each other. We hinted at it. Well, it was more than a hint. Kind of showed you quite a bit yesterday, but we're going to do it for real today, all right? So those are the four angles we're going to deal with. This time, we're going to deal with parallel lines, all right? So these lines are definitely parallel to each other. If I put a little arrow right there, oops, there we go again. Let's try this again. There we go. If I put an arrow there and an arrow right there, that means that these two lines are parallel to each other, okay? Or they could do this. Maybe they don't have those arrows there, but they name the lines, and you can name a line with just a lowercase letter, all right? If I had 2 points on here, I could name it line AB or XY or whatever, all right? But if they just put a lowercase letter here, we could call it line L. And by the way, they are lines, so I'm just lazy sometimes. I don't put the arrows on the ends, all right? But they're still lines. So you could have somebody say this. I showed you this yesterday, that line L is what? Parallel. That's the symbol for parallel to line M, all right? They're just two up and down lines like this. That means parallel. Everybody got that? Yes?
Yes.
Okay. Did I ever show you this one? Did I ever show you that symbol? I didn't show you that one yet? Okay. I think we're going to talk about that today. All right. But this means parallel. So line L is parallel to line M. Now we're going to have a transversal. Okay. Transversal is just a line that cuts those two parallel lines. Okay. It intersects those two parallel lines. Everybody got that? Transversal, right? I'll call it T for transversal. You can call it any letter, but T kind of makes sense. All right, and you've got a bunch of numbers, or a bunch of angles in here. Let's name the angles the same way we named them yesterday, okay? I think I went 1, 2, 3, 4 across like this. You don't always have to make that angle 1, that angle 2, and so forth. I just happen to do that. Then down here with this group, I said what, 5, 6, 7, and 8? Okay. Now what we're going to learn today, it's kind of what we learned yesterday. At the very end of yesterday's lesson, we learned this. We're going to learn which angles are actually equal to each other. Now, this is only true if the two lines are what kind of lines? Parallel lines. Okay, only if they're parallel. This is only true. I'm going to put a little arrow in here, a little arrow there. Again, there's two ways to show that the lines are parallel. One is by them telling you up here like this, and another one is by putting these two arrows inside. All right, not at the ends. They don't count. The one's inside here. That means that those two lines are parallel to each other. Everybody got that? All right. So now we have we have some theorems and a postulate. The first one's a postulate. The other ones are theorems that talk about the relationship between those four things that I just wrote down. Between the what? The corresponding angles, alternate interior, alternate exterior, and the consecutive interior. Three of them are kind of the same. All right, so let's do this. The corresponding angle, we have a corresponding angle postulate. What's the difference between a postulate and a theorem? They kind of look the same. If I would read this postulate to you from the book and I would read the postulate to you, or the theorem to you, they would sound very similar to each other, and it's hard to tell which one's a postulate, which one's a theorem. So how do I know which one's a postulate and which one's a theorem? Because a postulate, you do what? You just accept it, what? We talked about this earlier in the year. Might have been a while, but I'll tell you right now. A postulate, and I just shorthanded it. Let's write out the whole word. Postulates. All right? A postulate is just a statement that you just accept as fact, all right? They tell you that this is true. We're like, all right, I'll believe you. It's true. You can't really prove it. Everybody with me on that? Have you heard that before? I think you heard that before in the first chapter. I think the first chapter we talked about that. Anyway, if you didn't, now you have. Now, we also have some that are theorems, the rest of them. Okay, so that alternate interior angle one, the alternate interior angle, that's a theorem. What can you do with a theorem that you can't do with a postulate? You can do what to it? I use the word, not solve it, but prove it. Very good. Okay, you can prove it. Now, we're not going to, in this class, we're not going to prove these theorems, all right? I might show you a little bit of a proof, but I'm not going to show you a big, long, formal proof. A lot of geometry classes spend a lot of time doing proofs. Since I came back to teaching math, remember I was gone. Well, I wasn't gone. I was still here, but I quit teaching math for like 10 years. All right, I was doing that media stuff. I taught video and photography and all that kind of thing. But before that, I taught math for 25 years, and most of those years I taught geometry. And most of those years, almost all those years that I taught geometry, we did proofs. We did a lot of proofs. In those 10 years, I started thinking about it. I was like, you know what? I don't know how important those proofs really are to do. There's other things that I want to concentrate on more than the proofs. And you should be very grateful for that. If you ever go to your parents or go to a grandparent or somebody, aunt and uncle, somebody like that, and you say, what's the thing that you hated about geometry the most? All right, because most people aren't going to say, oh, I love geometry. I tell you, out of all the math classes you ever take in high school, if somebody polled somebody after they graduated, they say, what was your least favorite class? Almost everybody's going to say it's geometry. Because geometry is different. Geometry makes you think. A lot of people don't like to think. On this, you have to think. It's not just a series of steps that you follow. Algebra is like that. Algebra is like, okay, you add this to both sides, you divide this by both sides, and you do it the same way over and over and over again. And you hardly have to think. In geometry, you have to think, right? And that's what a lot of people don't like to do. It's not always the teacher. Sometimes it is. Sometimes people hate me. That's fine. I get it. All right. I'm not that lovable sometimes. All right. But it's the subject itself, geometry. It makes you think. And that's what we're going to try to do in here is we're going to try to think. So proofs make you think. I'm not going to do a whole lot of proofs in here. I'm not going to do any formal proofs whatsoever. But we will talk about why this thing is true sometimes, not all the time. Anyway. That's the difference between a theorem and a postulate. A postulate, you just accept it as truth. They tell it to you. You're like, all right, sounds good. I'll believe you. All right, that's a postulate. A theorem, if somebody is really inquisitive, right, and saying, well, I don't know if I agree with that. Prove it to me. A theorem, you can prove. All right. Sometimes the proofs are very difficult. Sometimes they're not that bad. They're pretty simple. All right, but you can prove a theorem. Everybody got it? All right. So. What's the other theorem? The others are theorems, the other three. So what was the other one? Alternate what? I'm sorry, I forgot the interior, didn't I? Alternate interior and then alternate what? Exterior angle theorem. I'll just shorten theorem a little bit. And that's a theorem as well. And what was the last one? Consecutive. I'll just shorten that. Interior angles. That's a theorem as well. All right? So we've got 4 of these things, and they all tell you something. We're not just content with saying, oh, 1 and 5 are corresponding. I mean, that's good. You're going to have to do it on a quiz, but that's not enough. I need to know something about 1 and 5. There is a relationship when you have parallel lines. If you don't have parallel lines, this is not true. Everybody with me on that? If these lines are not parallel, what I'm going to tell you right now is not true. It's only true when the lines are what? Parallel to each other, okay? So here we go. The corresponding angle postulate says this, that all the corresponding angles are equal to each other. Everybody got that? So the corresponding angle postulate says all the corresponding angles are equal to each other. Same thing with alternate interior angles. All the alternate interior angles are equal to each other. So it's important to know which ones are alternate interior, which ones are corresponding, because their corresponding ones are all equal. Alternate interior ones, they're all equal to each other. Same thing with alternate exterior. Alternate exterior angles are all equal to each other. But now comes that consecutive interior. Now let's just take a look at that before we get to the consecutive interior. Let's just take a look at it and just look at it and like, does it make sense that they're equal to each other? All right, let's just look at it. We don't normally just look at it and say, yeah, it looks like that one's equal to that one. We don't usually do that, but in this case, I'm going to have you do it. All right, so look at angle 1. What's the corresponding angle to angle 1? Angle 5 is, right? Now look at angle 1 and look at angle 5. If I had a little protractor and I put it up here and I measured it, guess what would be true about angle 1 and angle 5? They're exactly the same. Okay, so every corresponding angle are the same. All right, give me some other corresponding angles. Angle 2 and what?
6.
Angle 2 and 6. So look, angle 2 is going to also be equal to angle 6. Does that mean that 1 and 2 are equal to each other? No, because they're not corresponding, are they? So angle 2 is different than angle 1, so I'm going to put 2 arcs, right? And then I'm going to put how many here? 2 arcs right there. Okay?
Wait.
Go ahead. Sure? All right. Let's keep going. I don't know if we talked about this or not. I think in the other class we did. I know for a fact in the other class we did. I can't remember if we did here. Did we talk about this, vertical angles? Do you remember vertical angles? Okay. So I'm going to teach it to you right now. It's very simple. If you have two lines that intersect each other, okay, they're not parallel to each other, because if they were parallel, would they ever intersect each other? No. All right, so I got two lines that intersect each other. Do you see the angles that are across from each other? See this angle right here? Which one's across from it? This one down here. Do you see that? What do you think looks like might be true about those two angles? They're the same. Exactly right. They're equal to each other. Okay? We call these vertical angles. Somebody in my other class said, why don't you just call them opposite angles? Well, that might be a good name for it, but that's not what we use. Okay? We use vertical angles. It's very important. Vertical angles. So what do you think is true about the vertical angles? Like these two right here are vertical angles, and then these two right here are vertical angles. What does it look like is true about the measurements of those angles? They're the same. That's right. So this angle right here is equal to this angle down here. This one with two arcs over here is equal to this one with two arcs. So what's true about vertical angles? Vertical angles are always what? Equal to each other. All right? It doesn't matter how you draw the lines. Any two lines that intersect each other, that cross each other, you got two sets of vertical angles, and both of those vertical angles are equal to each other. So these two are equal to each other right here, and then these two right here are equal to each other. Everybody got that? Now, let's jump up here. What else is equal to angle 1 up here in this group of 4? Is there anything else that's equal to angle 1 that we know of? We just talked about it. We just talked about it. No, in this group right here. In this group right here. What else could equal angle 1? Why, Neil? You said 4. And you're right. Why? Why is angle 1 equal to angle 4?
Well, what you just showed, it's like the opposite.
Give me the word. Give me the word. It's right there in front of you. Say it. Vertical angles. That's what I was looking for. They're vertical angles. So look at 1 and 4. They're vertical angles. What's true about vertical angles? They're what? They're equal to each other, okay? That's what I'm trying to get at. So look at 1 and 4. What's the relationship between 1 and 4? What are they to each other? They're vertical angles, right? So what's true about vertical angles? They're always what? They're always the same. They're always equal, right? So if that has one arc, then guess what? I can make one arc right here. Everybody with me on that? Look at 4 and 5. What's the relationship What word do we use? We got 4 different theorems, okay? Which one are 4 and 5? Are they corresponding? Are they alternate interior? Are they alternate exterior? Are they consecutive interior? 4 and 5, what are they? They're alternate interior. They're alternate interior angles, okay? Look at 4 and 5. You remember that? They're interior because they're between the 2 parallel lines. Remember talking about that yesterday? Yeah. And they're alternate because they're completely opposite, right? So with these 4 angles, 3, 4, 5, and 6, 4 is up here at the top right. Where's 5? It's completely opposite. It's down at the bottom left. Do you see it? So they're alternate. And they're interior because they're between those 2 parallel lines. So they're alternate interior angles. Look what's true. If that's got 1 arc and that's got 1 arc, they got to be what to each other? They got to be equal. So what's true about alternate interior angles? They are what? They are equal to each other. Okay? Let's go to angle 2. What can we see up here in this group of 4? Up here. 1, 2, 3, 4. What is equal to angle 2? Angle 3. Give me a reason why. Why are 2 and 3 equal to each other? Because they are vertical angles. You got it. Now we're getting the hang of it. Does that make sense? So 2 and 3 are vertical angles. Now check this out. 3 has 2 arcs. 6 has 2 arcs. So what must be true about 3 and 6? They got to be the same. They got to be equal to each other. All right? And what's the relationship? You know what I'm saying by relationship, right? What's the name that connects them? 3 and 6. What are they to each other? They're equal, that's true, but what's the relationship? It's one of these. Say it. Alternate interior again, okay? So 3 and 6 are also alternate interior. And so the 3 and 6 are equal to each other as well. Everybody got that? All right. So we know that 1 and 4 are equal, 2 and 3 are equal. We know 1 and 5 are equal. We know 3 and 6 are equal. 4 and 5 are equal. All right. What about 7 and 8? What's 7 equal to down here? 6. So if 6 has 2 arcs, how many arcs are we going to put with the 7? We're going to put 2 arcs with that. What's true about 5 and 8? Why are they equal? Give me a reason. Look on the screen. They're vertical angles. They're vertical angles, okay? And what's true about vertical angles? They're always equal to each other. So if 5 has 1 arc, then 8 has 1 arc. So look at all the things with 1 arc. What's true about all the things with 1 arc? They're all equal to each other, aren't they? Everybody see that? Yeah? Because look, 1 and 8, they're equal to each other. Well, what's the relationship? Here we go again with that word. What's the relationship between 1 and 8? It's one of these things. What are they? 1 and 8. They're not interior because they're not in between the 2 parallel lines. They're exterior. What's the only one that has exterior in it? Alternate exterior angles. That's right. Okay, alternate exterior angles. And what's true about alternate exterior angles? They're what? They're equal to each other. So 1 and 8 are alternate exterior. And what must be true about those 2? They must be equal to each other. You getting that? All right. We've done these 3. So we've shown that corresponding angles are equal to each other. We've shown that alternate interior angles are equal to each other. We've shown that alternate exterior angles are equal to each other. What's the one thing we haven't talked about just yet? The consecutive interior angles. Now, did I say that they're equal to each other? Okay, I did not. Because which angles are actually consecutive interior angles? Well, they're interior, so they got to be either 3, 4, 5, and 6. Okay? So which ones are the consecutive interior angles? Like 3 and 6 are alternate interior. 3 and 5, that's right. Remember I said they could be same side interior angles? Remember that? Okay, so 3 and 5 are on the same side of the transversal. They're interior angles, so 3 and 5 are same side interior angles. But we don't use that phrase. Other books do. This book doesn't. This book uses what? Consecutive interior angles. So 3 and 5 are consecutive interior angles. Are they equal to each other? Is angle 3 equal to angle 5? Clea, you shook your head no. Why'd you shake your head no? Exactly right. 3 has 2 arcs. 5 has 1 arc. Okay. Also, look at 3. What kind of an angle is angle 3? We talked about this at the beginning of the year, the different types of angles. That's a right angle? It's acute. Look at 3. 3 is an acute angle. Look at angle 5. What's that? It's obtuse. Is there any way an acute angle is going to equal an obtuse angle? No. It's it flies in the face of the definition, right? Acute means it's less than 90. Acute means less than 90. Obtuse means greater than 90. You can't have one that's equal to the other. Agreed? All right. So they don't equal each other. But let's do this. Okay? This is kind of a proof. It's like a sneaky little proof. I want you to look at 3 and 4. Okay? We're going to look at 3 and 5 in a minute. Okay? Look at 3 and 4. What do you think the measurements of those angles do? Angle 3 and angle 4. What do they form? Let's do this in another color. Look at angle 3. Angle 3 goes to here, right? And angle 4 goes to here. What? Not a circle. It's 180 degrees. It's a straight line. It makes a straight line. Now that thing right there, that little arc right there, yeah, it's kind of like an oval. It's kind of like a half circle, but it connects from here to here. So that line is a what kind of a line? It's a straight line, isn't it? Everybody see that? How many? I think you said it, Neil, didn't you? How many degrees? Did you say that? How many degrees is a straight line? 180 degrees, okay? So what must be true about angle 3 and angle 4? They add up to 180. It's exactly what I wanted to hear, okay? Angle 3, and angle 4 add up to 180 degrees. Now, let's take a look at this. Look at angle 3 and look at angle 5. Well, 5 is the same thing as what? As 4. So if 3 and 4 add up to 180 degrees, tell me something about 3 and 5. They also add up to 180 degrees. Agree with that? So for instance, let's put some numbers in here, okay? When you stick some numbers in here, it kind of makes a little more sense, all right? So give me a nice easy number for an acute angle. What do you think that is about right there? How many degrees do you think that is? 80? I don't know if that's 80. Oh, it's definitely not 90. It's definitely not a right angle. It's acute. It could be 60. Yeah, let's say it's 60, okay? It's probably a little less than 60, but we'll say it's 60. So let's say angle 3 is 60. Then what's angle 4 have to be? What is it? 120. Where'd you get 120 from? It's 180. It adds up to 180. So what math did you do? What math did you actually do? You subtraction, right. You went 180 what? Minus 60. So 180 minus 60 is how much? It's 120. So if this is 60 degrees, they add up to 180. So this has got to be, angle 4 has got to be what? 120 degrees. Agreed? All right. Now if angle 4 is 120 degrees, tell me what angle 5 is going to be. It's going to be the same thing. So give me a number. 120. Everybody see that? So what's true about angle 3? What's true about the consecutive interior angles? Angle 3 and angle 5. What do they add up to be? 180. So are they equal to each other? No. But they do what? They add up to what? 180 degrees. And we have a word for that in geometry. Okay? I don't know if we've done that word yet, but I'm going to tell it to you now. Instead of saying they add up to 180, we say that they are supplementary. Have we done that word yet? Now we have. Supplementary. Supplementary means, what do you think? That they do what? They add up to what? 180, okay? So supplementary, that's the word that we're going to use, okay? So when I'll look at two angles and I'll say, hey, look at those two angles. They're supplementary. What does that mean when they're supplementary? They add up to 180, exactly. Are you with me on that? Okay, got to keep the vocabulary straight, okay? So supplementary means that they add up to 180. So our theorem, our consecutive interior angle theorem, says that if you have two parallel lines cut by a transversal, the consecutive interior angles are not equal, but supplementary. Thank you. All right. They're supplementary to each other. All right. What's true about the corresponding angles? They are what to each other? Equal. What's true about the alternated interior angles? What are they? What's true about the alternated exterior angles? They're equal. What's true about the consecutive interior angles? They are supplementary. That's the word that we use, okay? Learn that word, supplementary. While we're at it, I'm going to show you another word. We're not using it right here, but actually in a minute, we could be. All right. Here's another word. instead of adding up to 180, adding up to 90 is pretty important, okay? So when two angles add up to 90, thank you, all right, they are called complementary. Write it down. All right, so when they add up, when they add to be 90, then they're called complementary angles. Everybody see that? When they add up to 180, it's supplementary. When they add up to 90, it's complementary. Some people have a difficult time remembering which one's which. Here's how I remember it. It's kind of a dumb way to remember it, but this is how I remember it. Okay? 90 comes before 180. Would you agree? Okay. C for complementary comes before what? S for supplementary. So how do you know which ones go together? The 90 and the C go together. The 180 and the S go together. Did that make sense? That's how I remember it. So there you go. Yes. Fill out a pass. Let's see. Okay. Get my papers right. Remember that little symbol I put up here and I erased it? Do you remember what it looked like? Yeah, like an upside down T. That's a good way to say it. All right, so one went like this and one went like that. Okay? What kind of angle do you think that little thing forms right here? This straight up and down one and this one. A 90-degree angle. All right, so how do we show a 90-degree angle? I think I've shown you this before. Yeah, because we talked about right triangles or right angles anyway, not triangles, but we talked about that. Do you remember the symbol to show that they're perpendicular? Yeah, the little box, okay? So the little box right there. That's why we use that symbol. We don't put the little box there, but that little symbol right there means, I already said it, I kind of gave it away. This symbol means parallel. What do you think this symbol means? They add up to 90, but what are two lines that add up to 90? Yeah, okay, that is true. The two angles add up to 90, but the two lines, they form, it starts with a P. You'll know it as soon as you hear it. What is it? Perpendicular. Very good. Okay, perpendicular. All right, we've used that word before, right? Yeah, we've used it. So perpendicular. So let's keep that in mind. So what we're going to do here is another theorem. Judea, what do you need? No. I'm sure it is. Write a pass. Can't go without a pass. So if you really got to go, you'll write the pass. All right, these two lines are parallel. How do I know they're parallel? Because I did what to them? Put those little arrows in between them, okay? It's not the arrows on the ends, okay? It's somewhere in between, okay? The arrows in between, all right? Now, this line right here is still a transversal, but it's more of a special transversal, okay? What does it look like is true about this transversal and this parallel line? How do you think they form each other? Or how do you think they form each other? What do they form? A 90 degree, right. So I could put a little what there to show it's 90 degrees. That little box. Oops. Keep clicking that button. So there's a little box right there. All right. So let's call this, let's call it T. And we'll call this L and M again, just like we did earlier. I don't know why. The books always like to put L and M, so that's what we're going to put. So what must be true about line T and line L? They are what to each other? Give me the word. Perpendicular. Well, they're perpendicular. The lines are perpendicular. Okay, complementary means two angles that add up to 90. Do I see two angles that add up to 90? No, I don't. Okay, I see one 90-degree angle. I see another 90-degree angle, but I don't see two angles that add up to 90 degrees. Do you? What would that look like? Watch. What if I had this and that? Now, here are two angles. See that angle 1 right there? Quit clicking that button. 1 and 2. Do you see that? those two angles do what? They add up to 90 degrees. So angle 1 and 2 would be considered what? Give me a good word. Complementary. They would be complementary. There's no complementary angles here. There's no angles that add up to 90. There's just that one 90-degree angle. So here's what the theorem says. This is called the perpendicular. Here, we haven't written perpendicular, so let's write it out. So perpendicular transversal theorem. I'll just put trans right there and then THM. I shorthand a lot of stuff, okay? Perpendicular transversal theorem. What that says is this. Everybody watch. It's given that the transversal is perpendicular to line L. They tell you that that's 90 degrees. What do you think must be true then about the angle down here? They didn't tell you anything about this, but what can you figure out? It's going to be the same thing. It's going to be 90. And there's a good reason for it. Because look, these right here, this angle right here and this one down here are corresponding angles, aren't they? All right? This is at the top right. This one's at the top right. What's true about corresponding angles? They're equal to each other. So if this is 90 degrees, then what? That's 90 degrees. What we just said right there, what we just did, was basically a proof. Okay? We just kind of proved that theorem in a very easy general way. Okay? All right, that's what that theorem says. Now, let's do an example. We got 5 minutes. So let's do an example. This is kind of stuff that you're going to see on the homework problems. All right, we've got 2 transversals this time. Oops, let's start that up here. That's better. We got 2 transversals. And these 2 lines right here are parallel lines. This is example 2 in the book. So write it down. Let's see, they call that line D. They call that transversal line A. This line is B. This one is C. They are parallel to each other. They also tell you that that's a right angle right there. They call this 2, 3, and 4. This is 1. This is 5. And this is 6. And they tell you this. Now, this is why we learned all that algebra. This is why we took 2 weeks to learn algebra, because they're going to give you something. They're not just going to give you numbers for angle 1. They're going to give you this. This is what they tell you. This is what's given. They tell you that angle 1 is equal to 7y minus 15. Okay? We put it in parentheses, put a little degree symbol on the outside. Okay? That's how they usually write that when it's an angle. And they also tell you something else. They tell you that angle 2 is 10 times y plus 11, and then they put a degree symbol out there. And what they want you to do is they want you to find all those missing angles. Okay? You need to find what angle 1 is, what 2, 3, 4, 5, 6. So there's 6 parts of this problem. You got to find all 6 of them. All right? So how in the world are we going to do that? Well, I got to find some kind of relationship. Are these equal to each other, angle 1 and 2? Look at angle 1. Look at angle 2. Are they equal to each other? Are they corresponding? Are they alternate interior? Are they alternate exterior? They're not. Look, 2 is exterior, 1 is interior. All right? So they're not corresponding. They're not alternate interior. We just don't know what they are. But let's find something else. Let's take a look at angle 3. Is there a relationship between angle 1 and angle 3? Look at that angle right there and look at that angle right there. I got parallel lines. I got me a transversal. What's true about 1 and 3? Out of those 4 things that we've talked about today, which one are they? Angles 1 and 3. Are they corresponding? Are they alternate interior? Are they alternate exterior? Are they consecutive interior? Which ones? They're consecutive interior angles. 1 and 3, look, they're interior because they're in between those 2 parallel lines. Okay? They're not on different sides of the transversal, are they? So they're not alternate anything. Okay, so what are they then? What's the other interior one? They're consecutive interior angles. So what must be true about angle 1 plus angle 3? They add up to be 180 degrees. Everybody with me? Okay, but now they don't tell you what angle 3 is equal to, do they? But they do tell you something else. They do tell you angle 1, right? So I could put what angle 1's equal to in for that. And they tell you angle 2. But what's true about 2 and 3? Look at 2 and 3. Come on, we talked about this a lot today. They're not corresponding. They're what? Vertical. They're vertical angles. So 2 and 3 must be what to each other? They must be the same. They must be equal. Let's say equal, not the same, okay? Because they're really not the same angle, but they are equal to each other, okay? Everybody see that? So look, instead of saying angle 2 is equal to this, I could say angle what? 3 is equal to this stuff. Yes? All right, so here's what I'm going to do. Here's the work. This is the geometry. The rest of it is basically just algebra, okay? This part right here is the geometry, okay? We have to think. We got to look at it and see what goes with what. So angle 1, what is angle 1 equal to? 7y minus 15, correct? So watch. Angle 1, I'm going to do it down here just so I have some more room. So angle 1 is 7y minus 15 plus angle 3. Well, I don't really know what angle 3 is, but I know 3 and 2 are the same, right? So watch. 3 and 2 are the same. So I could add what? 10 times y plus 11. What's that equal to? What do they add up to be? What are these two angles, 1 and 3, what do they add up to be? It's right here in front of you. It's equal to 180. So that's equal to 180 degrees. Look, this was angle what? 1. Do you see that 7y minus 15? That was angle 1. This 10 times y plus 11, that was angle what? That was angle 2, or in this case, angle 3. So this was angle 3 as well. So watch what I'm going to do. Don't leave. I didn't dismiss you. Stay in your seats. So watch what we're going to do. We're going to do what we've done in the last couple weeks. All right? We are going to solve for y. So let's do it really quick. 7y minus 15 plus distribute 10y plus 110 equals 180. Tell you what, I want you to do the work and then come up with what y is equal to. All right? Once you get what y is equal to, then you could plug them in. And then you could solve for angle 1, you could solve for angle 2, angle 3, and then it just all kind of falls together, okay, after that. All right? So your homework is to do this example, okay? Tomorrow I'll assign the actual homework. So it says that we have homework, but we're not going to do that, okay? So finish this example tonight for homework.